Alright, let's look at another example of surface integral. This one is rate of heat flow. Alright, let's just say that we have a temperature function, T of x, comma, y, comma, z. So this just tells you the temperature of whatever it is at the point x, comma, y, comma, z. Alright, then we want to find out the rate of heat flow through some surface S. Alright. So let's try to figure out the heat flow, right? So as we know that heat flows always from hot to cold, right? So if you want to find the direction at which the heat is flowing, how do we find out? Right, so let's just say heat flow is some sort of a vector field. So I'm going to call it vector F, vector field F. All right, then think about this. So we know the temperature, right? If you look at the gradient of the temperature, what do we get? Right, remember that the gradient of a function is the direction of the most increase of the function. So gradient of T is the direction of the most increase in temperature, which is actually the other direction. So it actually moves in this direction. So the gradient of T actually points from cold toward hot. All right. So if you want to go from hot to cold, you have to put a negative sign to reverse the direction, right? And it depends on the material. So if you have like a metal object or something like that, and the heat flow would be faster. And if you have like a styrofoam or something like that, heat conductivity is very, very low, so it's going to be very slow. So, but it's going to be proportional to negative delta t, gradient t. So we can see that we have some constant k. So they use k, capital K as a constant. So k is a conductivity constant. All right. So if you want to find the rate of heat flow through the entire surface S, all you have to do is do the surface integral. So it's going to be surface integral over the surface S, right? So the heat flow, and then you just have to do d vector surface S, which can be which is the same thing as surface integral S, right? F is negative k gradient of the temperature function, then take the dot product with the normal vector and a d surface area element. All right, that's it. I hope that this was clear.